welcome to Lab 2. So, what is the lab about, Mike?
Okay, this is a continuation from Lab 1 and exploring a little bit more of the NLTK toolkit, having a look at Matplotlib to draw some plots, and then trying to tie all this together. We haven't looked at this lab script yet, so we're going to work through it off the cuff and see what problems we come up with.
Okay, so we're going to see some graphical stuff this time, right?
We're going to do some. First of all, we're going to start with a little bit of a recap from what we've had.
Good.
So
my memory's like I said.
We'll quickly run through that. If we have a look on number 2 there, do you want to recap that, and I will just start writing it in.
Okay, so the first thing we've got to do there is import NLTK. Remember, we're inside the Python shell here. Now, those of you who are a little bit more advanced at Python will obviously know you can do this inside a text editor as well and run it. The obvious danger here is we lose the code as soon as we shut it down. So what have you done there? You've just imported the book, which is good. And we're just about to import RE, which is the regular expressions. Now remind me what regular expressions do?
It gives us a very powerful method to be able to search through vast amounts of text for particular patterns.
Okay, and that was the one that we did something in Monty Python script, didn't we? That's right. We took out all the tokens associated. We shouldn't use the word tokens. We took out all of the symbols associated with the HTML page, and we just returned the text. Which we could have. Someone did it in Beautiful Soup, didn't they?
Yep.
But we just decided to do it with the RE as an exercise because that was quite a nice way of doing it. So you're converting to lowercase.
Well,
we're tokenizing.
Yeah, we're grabbing the tokens and we're working with Moby Dick. So our variables are MD to represent Moby Dick at the beginning.
Yeah. Okay. Yeah.
So we've got the tokens from the Moby Dick text.
Yeah, and we've got no punctuations. We're converting to lower.
We're going to loop through that, and we're going to use a regular expression to find all the words.
Right. Okay, so just run past me the MD tokens equals no punt word dot lower thing again. We used that once before, didn't we?
Yeah, what we're doing here is first of all we're lowercasing the word, or we're doing that after we found it actually. So first of all, what's happening here is we're looping through all the tokens, and we're searching for a word using a word pattern, which is a piece of text represented by a space before and after.
Yep.
And then if we find one of those words, we're turning it out of the loop into the lower.
Into the lowercase. So we're going through the entire book, and searching for words and words alone, and we're converting them to lowercase. Good?
Yeah, okay, so let's run that. There we go.
And the next line, we can see the length of what we've just created, right?
The N at the beginning represents number, so number tokens of Moby Dick. See how the variables are helping us remember what they're in?
Yep. And that's just the length of that object that we created there. The MD.tokens no punt, which we created in the previous line. So that's the list of words with no punctuations and just the spaces in between.
And now we're going
let's have a look how
let's have a look. So we have
how
a look
long it is. So
okay, let's have a look at N tokens MD. See what we've got there. 218,621.
God, no wonder it takes so long to read a book.
Okay, and now what we're going to do is we're going to compute an MLE, a most likely estimate, the probability or most likely estimate, which is the count of the word wow.
That's amazing.
So we're going to type PMLE.
So this is going to tell me the probability of that word inside that list of words. But this is, there'll be multiple occurrences in there, won't there? So this isn't the set thing that we did last week, is it?
This isn't all a vocabulary or a bag of words. This is just looking at it's taking account of how many times whale appears. And we've lowercased everything, so if there's a capital whale or a lowercase, a capital W at the beginning.
It doesn't make any difference, they'll both score,
And we are dividing that by the number of tokens. So we're casting that into a float, or we're type converting it into a float.
Okay, and we can already see an answer on the lab script here, but we'll run it anyway. So now pmle.md.
There we have it.
Ah, look at that. So
So that's the simplest way of calculating a probability is a most likely estimate.
so remember that 1 is 100%. So that number may look very small, but it's not actually that small because that's 0.05%, isn't it? So half a percent is the probability of a whale. So that means that's occurred a lot of times in that book, doesn't it?
Being as Moby Dick.
Well, I suppose it would
suppose
do.
it could be,
I
yeah.
suppose it would do.
Okay, so everything's been recapped here. So we're accessing the NLTK books again. So we have to remember to bring those in so that we can access the text from there. We're using a regular expression, so we need to import that into our Python environment. We are using the functions within the text1 object, which is Moby Dick, as we can see up there, text1 Moby Dick.
Yeah.
We're using that which has already been tokenized. We're finding the tokens there.
Yeah.
And then we're taking away the punctuation by using the regular expression search, and we're lowercasing. Then we're just counting what our length is, so how many altogether 218,621 words have been returned from this regular expression search.
Yeah.
And then we are simply using another function within the no punctuation list to count how many times the word whale appears.
Yeah.
And then we're dividing that by how many tokens we've actually got. And that gives us our most likely estimates.
Okay, that's good.
So that covers the
I'm just
first
going to turn my
part.
mailbox off, Mike, because that's going to pop something
I
up.
think
in a
I've done it.
minute. Oh, you've done it already, excellent.
That's the first. That's the recap on number
Something
2.
I just wanted to say here, really. I mean, you look at a lot of that, the script, the Python script there, and a lot of it doesn't make much sense when you look at it. Now, if that doesn't make any sense, you've got a problem with the syntax. It doesn't really matter because it's all contained in reference, and as long as you know what it does and what instructions to use to get the output that you're looking for, you can just mechanically use these, can't you? And that's what most developers do anyway. They just want to know how to convert something to lowercase. That's it, cut and paste into the code, right?
Yeah.
That's how I work. That's how I've always worked.
Yep. Can you think of a most likely estimate of a word that you'd like to find from the Monty Python script?
Monty
Holy
Python
grail.
script. Well, I think it's your. We're going to process the whole book.
It would be very, very quick to do
Okay.
now. We can copy
Okay,
this
let's
in.
process the whole book.
So we're looking at text 6.
Swallow.
Swallow.
African or European, but no, just the word swallow.
Okay, so
I would guess that occurs quite often, actually. Not as high as whale does, but certainly I'd expect that to be well above 1/100th of a percent.
so what about stone? Stone him. Was that? I thought that was Life of
No,
Brian,
that was like
wasn't it?
Brian, wasn't it? No, let's go for
Okay, let's go
swallow.
for swallows. So all I'm doing is I'm copying the same
That's
word.
the same as before.
I've just changed the text to text 6, which is our Monty Python.
Yeah,
and
gotcha,
Holy
gotcha.
Grail. So let's have a look at how many tokens we have for starts. So we have not so many.
Not so many, no, it's not very
11,602.
flowery language, that.
And then let's calculate the most likely estimate for the word swallow.
Yeah, it's obviously depending whether it's stemmed or not, isn't it?
Yeah.
Swallow or swallows, but we'll come to that
yeah, we
later
could,
about
yeah.
stemming.
Okay, and then we'll look at the result from the swallow. And then we have an estimate there.
It's quite low actually, but I thought during that film that occurred quite a lot of times, isn't it?
Yeah, definitely.
What's the average flight speed of a swallow? African or European?
Okay, so that wraps up question 2, and we will move on to a different video to tackle part 3.
Excellent, see you soon.